Hello. For this problem, the first part, let's see. The manager of a computer retail store is concerned that his suppliers have been giving him laptop computers with lower than average quality. His research shows that replacement times for the middle model laptop of concern are normally distributed with a mean of 39, so that's our mean, and a standard deviation of 0.5 years. He then randomly selects and records 35 laptops sold in the past. Round your answers 4 decimal places. So the first distribution, the capital X, that's using the population or the one given. And you use your mean and the standard deviation given in here. This is just helping you set up so you know when you're doing the problems down here which one to use. Now notice the second one, it has X with a line over it instead of the capital X. This is for the sample, and the sample was 35 laptops. So for this one, the mean is the same, but for the standard deviation, what you do is take the standard deviation of the problem and divide by the square root of n. And so the standard deviation was 0.5, sample size was 35, so we divide by the square root of 35. 0.5 divided by 0.0845. I think they want 4 decimal places. Yeah, 0.0845. So it's just the standard deviation divided by the square root of n. Now when we're solving the problems then, notice in the first one, see it says, what's the probability that one randomly selected laptop is replaced more than 3.8 years? Notice the next one says, for the 35 laptops, find the probability the average replacement time is more than 3.8 years. So this one's using the sample. It will use mean and standard deviation from B. The first one is taking any one of the randomly selected, so it uses the mean and standard deviation from part A. So for this one, what's the probability that one randomly selected laptop is replaced more than 3.8 years? So first let's find the value. On Excel you do equals, and then your norm, and we want the normal distribution. We want to find the probability or the percent. So double click on it, then it tells you what to put. You put your X value, 3.8, your mean, and this one was one randomly selected laptop, so we're using part A, 3.9, comma, standard deviation, 0.5, and then it wants cumulative. Our cumulative under the curve is 1, so you use 1 and hit enter. Now what this value is the percent below 3.8. It always gives a below, but notice they want above. So we need to, right here we could find our answer. You can put equals 1 minus, and then click on this and it will subtract them. Which is what we have here. So the reason we had to subtract by 1 is the formula gives you the percent below, and we wanted more than 3.8, so you subtract it from 1. Now for the next one, for the 35 laptops, find the probability that the average placement time is more than 3.8. So if we click on this, the only difference is the standard deviation. So I could go right here and replace the 0.5 with the standard deviation here. 0.0845. So all I did was replace that and then hit enter, and it found it and it subtracted it from 1. There you go. Now, the assumption of normally, is it necessary? The reason it's not necessary is our sample size was more than 30. And so the normal was not necessary.